Next, especially appreciative of Mikkel's dedication for getting the presentation pulled together during his leave. So glad that it worked out, and also wanted to acknowledge Mark Wood and the team from Oxford Semantics in connecting us. As a chief data scientist and AI lead, Mikkel leads Grundfos, which is involved in their enterprise transformation. I was unaware, but they're a $26 billion commercial pump manufacturing doing business in 52 countries. So a huge global footprint, and they're a leading heat pump manufacturer. He's leading a 4-year effort to digitally modernize scalable IoT, 500,000 pumps, and over 200,000 product types. A huge challenge. So enough on the why. A privilege to introduce Mikkel.
Having me here, I'm really stoked to be talking to the mountains of USA. My name is Mikkel, and I work at Grundfos. I'll just jump right into it and just introduce sort of my situation 4 years ago. So our world in Grundfos is about sort of these kinds of things, the technical places. Of course, we have a focus on the pump, but there's also a lot of other devices and sometimes connected things that we like to think about. And like many other companies, Grundfos is also heavily involved in selling digital offerings and so on, and moving to as a service. As Steve mentioned, we're kind of a big company, and this is just some metrics on it. So you have an idea about the organization I'm sitting in. Because I think my focus would, after discussing with Steve, I think my focus was a little bit about the journey of going from being the only guy, seems like, who knew anything about graphs, to now being sort of the center in a storm of a lot of data models and graphs and a lot of ontology projects running, and having between 5 and 10 ontologists in our company now working on pretty mature RDF stuff. So I'd like to describe that journey to you guys. So like most of you, I guess, data silos is a part of the world, is a part of our daily life. And this is especially the case for companies like Grundfos that has a manufacturing focus. So we are really good at producing pumps. We haven't been thinking digitally all the time. We of course use digital tools to produce pumps, but that has been sort of the extent of it until maybe 10, 20 years ago, when they started connecting pumps and started really ramping up. But having a lot of silos in a big company like ours means in real life, it means that when you need data, you find the right guy to talk to, and you get some data. Of course, this seems horrible, but it's actually worse, because this is more like what happens. You use a lot of time walking around, and then when you finally find the right person to talk to get data, he or she is talking a completely foreign language, and you don't understand anything of the data that will arrive in your computer. So what do? Of course, you look at semantic web. Another kind of part of our story is that we would like to go to self-service. We would like to make decisions based on data, maybe based on natural language processing and so on. But how do you do that if you have a very varied tagging language and varied code language across all of your data? The machine does not know that alpha 2 is a heating pump unless you tell it. So this is basically where I was. I started out in Grundfos as a data scientist, and this was basically one of the reasons why I really got interested in data models, data quality, and terminology, and shared understanding of data. Was this part of the comic I stole? Maybe I was a little more lucky than this poor data scientist, it didn't take 3 years, it only took 3 months or something like that to get the first data and so on. But this is, I think, nails the situation for many people in big enterprises, in big companies, in big manufacturing companies that are not born digital. So where are the data catalogs and where are all the standards? So now I'll just describe my journey towards having a full-time job and not enough time to do RDF all the time in a big company. I started out teaching math and programming websites and became a data scientist in Grundfos around 2017. Then I did a lot of data scientist work, AI, time series analysis, we did computer vision and so on. And I got frustrated, just like the picture you saw just before. So then I think it was a stroke of luck that I think Thomas Huber, who spoke yesterday, his manager talked to my manager or something like that and mentioned graphs. And then my manager said, Mikkel, could you check out that graph thing? And suddenly it reignited a past love for logic and graph theory, traveling salesman problems and so on. So I got to work on that, and I just Googled it and reached out, and I landed in an industrial ontologies foundry meeting in Norway, of all places, and it was a really great and a huge eye opener. This led to me going to the some of other conferences, but it also started some of the first knowledge graph projects in Grundfos. I will just show some slides from these projects soon, where we started out working on smart buildings. We started out working on, can we sort of remember the important bits about these connected heating systems out in hotels and so on in knowledge graphs, and we can, of course. We also looked at our production of our pumps. We had problems with sort of reacting really quickly to problems with materials. So if a batch of resistors, say, had a problem, that were spec'd wrong, then it was really important to figure out which products were these resistors put into, and if we could catch them before they left the factory and went on a truck going somewhere, we could actually save a lot of money. And doing this in the traditional relational data warehouse involves a lot of joins. So it will always take a special SQL expert, and it will still take a long time. So a lot of times we didn't catch the truck. We also worked on graph-driven chatbots for service, and I have to mention I was really in luck and met a lot of great persons in the industry from different companies. So none mentioned, none forgotten, but they know who they are. Going forward, we worked with procedural reasoning systems, another kind of reasoning. We built together with the consultants a chatbot based on that system. So we learned a little bit about representing our kind of service knowledge in different graphs. We built a digital twin demo. We sold it to Microsoft. We did ontology-based data access. That was a huge eye opener for some. So they said, "Oh, that's what machine readable is actually," and that was based on this old EU project called Optique that you can Google, and it's really fascinating. And Statoil back then did some really cool stuff with ontologies and data access and virtualization. That was really inspiring stuff. Around last year, in the middle of last year, my manager was also made director of data governance in Grundfos. So suddenly we got a new hammer to hit people with. We could go out and say that piece of data has to go under governance. So now you have to we have to talk about quality, and that was really helpful also for introducing data models to the higher up in Grundfos. And now We are working with product ontologies, sort of a backbone language for our pumps. We are working with IoT profiles to facilitate that Grundfos as a company remembers all the IoT profiles we encounter, even though it's different digital offerings that encounter them. They should be stored in a central repository. And for sure, we should always know our own products when they reappear in our digital offerings. And that's not a given, of course, as you would probably know. And the last thing is I presented last year, I think, at another conference on knowledge graphs. We're also working with cooling as a service, where we have, together with RDFox, developed a sort of a declarative questionnaire method that I think is totally underappreciated, and it will revolutionize the world when we figure out how to communicate it. Yeah. So I'll just jump quickly into a few of these examples that have sort of been stepping stones towards where we are now in Grundfos. So the traceability graph database, I cannot show everything, of course, it's a little bit sensitive, it's our production, but this is something that I think gives an idea. And this is true, this was true property graphs, it wasn't Neo4j back then, but it still looks cool, of course. But here you see, I'd like to get all of the impacted IDs out. It's not a system that's running now, so if you're trying to DDoS us, it will not help you if you try to find these systems. Another thing we did was this procedural reasoning system based on knowledge graphs of service fault finding and so on. And it's about a BioBooster system, and it actually makes sense to try to build a chatbot for such a guy, because these, I don't know if you see, there are some white pipes down there. That's actually ceramic filters that water will be pushed through it, and these filters will filter out certain bacteria that has been cleaning the water in these big process tanks for organic waste. But cleaning these sort of filters is a little bit messy when you are standing with a high pressure water gun cleaning these filters. There's a lot of things in the air, so it's really good that you can be totally protected inside some protective gear and just talk to a service assistant and not having to type stuff on a screen or a keyboard or something you have to clean afterwards. So we worked with that, and the way we ended up doing it was this is actually, it's not fake, it's not CGI, it was a chatbot running in AR, pulling up manual pages and presenting it to the service engineer on site, and it could sort of put it on top of the equipment it was talking about. And we also even made a small digitalization of how to disassemble a chemical drum and change out something in there. And all of this was based on knowledge engineering work, where we had interviewed the experts who built this system and who knew this system to the tiniest detail. How would you diagnose this kind of fault? What could be the potential problem, and so on. So this was, of course, this was a vertical proof of concept. It was never built into anything, but it was really inspiring to be part of this project. Another system that has been built in Grundfos, and now we are in a semantic web RDF graphs, is that we built a tool where people commissioning heating systems can actually sort of annotate in a schematic language they understand from their training as an electrician or a heat system engineer. They can sort of drag and drop the system they are seeing. They can connect the pipes from the forward and return valves pipes, and then a knowledge graph will be instantiated based on a shared ontology for that specific system. And forms will pop up and ask for the relevant information that you need to type in, so that we know enough about these systems. And then from that we can generate, for instance, a guide how to connect this to a controller. This is how we expect you to connect the different devices so that we know exactly which port is corresponding to which device and so on. And it was heavily inspired by all of these open, big, smart building ontologies out there. So there's IFC, there's Haystack, there's Brick Schema, and of course, the Smart Sensor Network and so on. Other ontologies we looked at. At the end, I think we took a subset of Haystack and just a sprinkle of Brick Schema. So we are really not behaving nicely, but it works. The next thing I would like to talk about is sort of consuming most of my time right now. It's our product ontology. So I finally sort of showed enough with these previous projects. Okay, that it can also work. So you're allowed to deal with the really fun stuff in our company, and that's of course what do you call the components of a pump? What kinds of pumps are there? How do you take it apart? What would it look like? Which kinds of part of hierarchies are there inside it, and so on. And it's not an easy thing. I think this is a common situation for many manufacturing companies having a lot of products. It is that different product silos or product teams of big product families have sort of drifted a little bit in the master data language. So there is a little bit of a technical debt of understanding everything in a golden record. Right now it works because people sort of talk to people and they share a lot of sheets, Excel sheets and stuff like that. It's horrible, but it works. And there's of course also a lot of intelligence pretty nicely hidden inside our ERP system in obscure rules all over the place. And we would like to build a product model that captures some of it, but also can assist people in choosing the right characteristics going forward when they introduce new products. So trying to sort of stop the disaster. And it's not easy because one thing is just figuring out how it should look, but you can't just change things to the nice to be simple way, because what will happen in all of our factories, will some production process break, and it probably will if you just do it without analyzing the impact, and analyzing the impact is not a trivial matter, especially when you have all these rules. So you have things being generated from other things and so on. It's not easy. What we're doing, I cannot show because it is our backbone, it is our heart, but it is heavily inspired, and it looks something like this. A really cool ontology that's hidden inside a data sheet ontology. There's a really nice valve and pump ontology in that document, and it's freely available on the internet. And I think it's amazing work they've done there. But it looks almost like that. Of course, when we pulled out our engineers that have been making pumps for 50 years, they did not totally agree with Hydraulics Institute in the US. That's not all the kinds of sheriff seals or something, So we have to do it ourselves, but they are slowly, the product information management team is slowly dawning on them how high quality the Hydraulics Institute actually made. And maybe it's something we will revisit at some time, that we will sort of make use of this ontology, I'm sure. What I would like to present here is also something that I don't know if it's been forgotten or if it is, but I haven't heard about it at this conference yet. But there is something to be said for tables, and there is something to be said for lifting data through templates. And we have sort of been extremely inspired by the people in DNV in Norway, Johan Klyver and others, who are working with, I don't know if some of you may have heard of the IBEL case for oil and gas master data. But it is a way of working, and it is a way of generating ontologies based on OWL2 and based on the standard ISO 15926 part 14, but also based on the thinking of Barry Smith and then BFO guys, where you allow the information engineers, we call them, the people who, and the product team, the specialists on the pumps, you allow them to curate the data they need to deliver in tables where you sort of lock the columns so they fit with the tables. But in Grundfos, tables are not scary. It's not something that people run away from. Tables for engineers in our huge manufacturing companies are sort of, they feel very familiar to these engineers. They've been working in tables for all their life, and they feel really comfortable around them. So if they can deliver their information, their knowledge in tables that we agree upon the meaning of the columns, they are actually really happy, and it sort of makes sense for them. They know what's going on. If you have enough engineers delivering enough information through these tables, they will inherently tell you something that's not logically consistent. And that's where that's one of the first places where the ontology will then help you, because if you lift it and check it for consistency, you can check, is it a logical story we are telling about our products? Are one engineer saying that this particular brand of pump has to have 4 impellers, and another engineer is saying that this other pump that's a sort of a special kind of this pump before has to have more than 8 impellers, then you have managed to produce a kind of pump that could not possibly exist, and this you can check for, and that's really nice. And it's part of the internal selling point that you can tell the data management governance organization, we can pull together all of this information and we can check it. And if we find some way to break the logic consistency, we can probably make templates and we can probably check for it. Maybe not in production graph, but we can make a sort of data quality graph where we can check it in also. Another nice thing about using CSVs tables is that it's easy to communicate the governance situation when you tell the people, you own this row, this is your row, and we can put that row into governance, and we can say it was changed on this day, and all the data that is sort of built based on that row, it should go into the version 1.1.0 or something like that. And in that sense, we can sort of manage the governance situation around the knowledge graph. This is probably not the only way. I'm sure it's not, but it is a way to handle all of these relations that are generated through the templates, because you can just look at what row generated these relations. And that's where the governance is anchored. You don't have this irritating problem where customer service 1 owns this entity and customer service 2 owns this entity, but they can be fighting forever on who owns the mapping between them. This is an example of another thing that's really neat. We don't have to know everything about modeling. We can just reuse these modeling patterns that has been developed in the oil and gas sector and has been proven and tested and is providing value in Norway at the moment. And we can even, there's even experts that we can hire in, and there are students being trained that understands this sort of templating concept. So we have a chance of not having to train everyone totally from scratch if we want to ramp up. Another project is our IoT profile hub, where we're looking at sort of organizing these IoT profiles. Grundfos has a ambition of connecting 1 million devices like tomorrow. We're not quite there. I think it's okay. I totally tell you that, but that's the ambition. So how do we manage all of these sort of IoT profiles? We can have sort of a device-specific binding info, and we want to map it to an enterprise data model. And in order to achieve that, we have put in place this system where we read the embedded software documentation. Whenever some of the coders make new embedded software, they generate artifacts that we consume. We lift to the graph, and we actually use other templates again to sort of in a huge landing zone where we have all of the device type profiles. Then we map it to a generic IoT data model, very inspired by the Web of Things RDF ontology curated by the World Wide Web Consortium. And then we have our connectivity teams. They are consuming these profiles, and it's sort of decoupling the sort of knowledge about how to pull out pressure from this type of pump or this type of motor valve or something from the specific IoT code. Because typically our pumps, they live 50 years or more, but I have not heard of any IoT project yet that have lived for that long. So it makes sense to sort of keep the parameters that you need to remember to talk to that pump in a different place than the specific IoT project of the given day. So these are the current projects that I'm in at the moment. We have IoT mappings, we have smart buildings, cooling as a service, we have customer data model coming up, we have a lot of our factories, we're working with our PIM products, but we also actually, not from my hand, but they also arrived at RDF graphs for something called the Darwin information type architecture, where they are using knowledge graphs to modularize our manuals. That's the quick way of saying it. And at the center of everything, there's a unit of measure and some sort of low-level ontologies that are super important to get right. And I'm enjoying building those these days. At the end, I'll just say, okay, there are some coffee machines conversations that you probably know that you have to work around when you are in a company like ours. And I don't have time to go through all of them, but you probably know them. So do we buy, do we make? Why are you the only guy talking about these ontologies? Didn't good old-fashioned AI go away? Is it a glossary? And so on. And there's, of course, the answers are all of these things, as I sort of mentioned going through this slide deck. We really like its open standard. We like that we can reuse modeling patterns. We can check for consistency. We can check with Shackle. We can check all over the place. We can even make data quality JSON schema files produced from the ontology, and so on. And we have IDs for concepts. That's a really cool thing. We can make these views on the ontology and so on. And for some of the last things, I thought I would just show you some of the slides that has been most useful in Grundfos for the last 4 years for sort of telling the story. So one of them is that, okay, point-to-point wiring of information is not pretty and it's not nice. Why don't see if we can do something like PTVs did for electronics? And there is a math exercise that some managers really enjoy talking about. So how many direct mappings would you have if you wanted to totally connect 4 data sources? Well, you'll have 6 data mappings. What if you have 18 data sources? Well, it turns out you have 153. And what if you more realistically have, I don't know, more than 60 data sources? How will you keep these mappings in the air? Then they listen. Okay. Other kind, my foot in the door is also sometimes that I say we need these enterprise languages to tag our training data, or else we will never catch up with the big players. We need to have a consistent and physically logical and physically meaningful tagging of our training data for all kinds of predictive maintenance and so on. The last slides here. Where are we going from here? We are making an ontology tool that we hope we can give back to the community and open source as much as possible of for having the people work with these tables. And of course, the cool thing about it is, again, we can work with the governance around it. We have stolen approval status and model status from the Danish government. That it turns out that the Danish government is also using RDF behind the scenes to integrate a lot of UML data models coming from all kinds of part of the digital Denmark. And finally, we have to find out how to make the developers choose us and choose our data deliveries. We cannot do this top down. It has to be sort of, they have to see it as way more delicious than trying to just reinvent the wheel in every digital project. And part of that is, of course, things like Trinity RDF and GraphQL and JSON schema and so on, which I have mentioned. That's basically what I have prepared. If you want to talk, please reach out. I would really love to talk about these things.
Great. We had a few questions posted into the Q&A. I will just bring them up on the stage here, if that's all right. Maybe
yeah, sure.
Answer some of those. There's our first one.
Should I go out of this? Can you please share some real-time challenges with mapping and design data source ontology? Yeah, so maybe the data source, I guess this is towards the IoT data source. I think when when I walked around in our digital offerings, I were part of many of them and talked to the people who are responsible for knowing how to connect and storing all of the master data that would enable the team to connect to all the devices they wanted to talk to. It was just always the case that they hard-coded business logic into whatever database or object structure they were storing this stuff in. So a challenge for that is to, of course, then convince them that we know what a data point is, and we also know what metadata around a data point there are. So for instance, do you call it pressure underscore average and pressure underscore mean and pressure underscore max? And do you also call it pressure underscore mean underscore estimated and pressure underscore measured underscore average? How do you go about naming it? And we've actually had a lot of work on just saying, no, there's actually hints for us in, for instance, the ISO 15926 way of working and what they have released. There are some ways of thinking where you say, when you measure IoT data, when you measure sensor data, there are things like quantities, units of measurement, qualities of water flows that you are interested in, pressure, temperature, and so on. And these you can model, and then you can make shortcuts, but you should always be able to shortcut names for different combinations of these things. But it's important that you can double click on it and you can tell the full story. So for instance, we are going to have different dimensions for IoT data point metadata that are important. Like, is this 8-bit, is it 16-bit? Is it mean or max? Is it aggregated somehow? What is the window of aggregation? And all of these things. And we have to make an ontology where you, maybe by a class hierarchy, you can sort of get all of these metadata out in a usable way as a data scientist if you want to work with the data, but you also allow for the connectivity engineers to not drown in complexity and in a hugely over-engineered schema. So that means we are probably going to have a little bit of a redundant ontology where you have these shortcut names for stuff, but you know what it means in the complex language. Maybe that's what's pretty convoluted, but it's what we're working on right now, so it's filling my mind.
Great. We've got one raised hand here. Michael, let's see here. We should be able to hear you now, Michael.
Hi, yes, nice talk, Mikkel. A couple of questions, one small one and one bigger one. The smaller one is, although it's a very big deal for you, I was just wondering what your experience was with the different units and measures, ontologies, and which ones you used. But that's more of a technical detail. The other question is, what is your go-to benefit? In other words, what tangible benefits have you had over the years? People say, why are you bothering with knowledge graphs? Tell me on the ground, who loves this stuff and why does their life better day to day because of it?
Yeah. So the easy one, units of measurement, we like the OM2, for instance, ontology, that's pretty good. We have to extend it a little bit because we're also working with code snippets for transformation between units of measurement systems. There are some convenience things that it makes sense to put into our enterprise units of measurement graph.
Right.
And we marry it with SCOS concepts so that I can tag different sort of bundles of units of measurement so I don't drown different projects in it. And we can also make, imperial and so on. So that's basically what we're doing there. And for the other thing, I think the data governance really likes us because we have an answer when they say what are hierarchies. I can tell them what hierarchies is. I can pull them down a road of deepening of understanding and being more explicit about a hierarchy is not just a folder structure to the left in your platform. Whatever platform you open, there'll be someone who has built some kind of folder structure, and I can ask them, okay, what's the relation between these things that are on level 2 and these things that are on level 3? Is it part of? Is it kind of?
Yes, exactly.
And it's always, they are never the same when you drill down these. And it's
that's for sure.
And just being explicit about this, both pointing out maybe something that they had a feeling this was a problem and it was sort of hurting in different ways, but also having a solution for it, having these modeling patterns and saying, this is how we could model it. This is a good way to work with merologies. That's one kind of people. The other kind of people is just actually people working with metadata around smart buildings, for instance, just seeing them open this knowledge graph about a smart building in Protégé, actually, just navigating around and just saying, wow, all that knowledge that's in here, and then helping them just make a small Sparkle query, pulling out whatever information they need. That has proven valuable. People latecomers to a project like that, they have a really high source of explicitity. They don't have to call the former guy. They can just traverse the ontology and get up to speed. That's just two kinds of value we have had.
Thank you. That's excellent. Appreciate it. Nice talk.
Thanks.
Good luck.
Oh, sorry, cut you off a quick second early there, Michael. We had one other Q&A come through. Here we are.
That's a big yes. we definitely have we are using it for predictive analytics, but I'm not sure that the knowledge graphs are helping us yet. Sorry, maybe I should read the question. I don't know, but we are not using the knowledge graph so much for the production as is. I think maybe the smart buildings people will actually teach our connected factories a little bit about the value of having high amounts of information about the systems generating intelligence. But we definitely use our historic and IoT data and data for predictive analytics and quality control. So that's a yes.
Great. And let's see, we've got Dave here. All right, Dave, we should be able to hear you.
Yeah, hi, Mikkel.
Hi.
Great talk. I'm always excited to see somebody else that much further down the road. That's terrific. One thing I wanted to ask a little bit more about, if you could go into a little bit more what you're trying to do with your ontology modeling tool, and maybe drop a link somewhere. If, you said you're going to try and make it available. What particular problem are you trying to solve with it?
There are 3 problems actually we want to solve. And the first order of business is to get our product information people more productive. They need to be able to offload all they know about pumps and the different kinds of pumps into the ontology and also the knowledge graph. So it's about having just a tool where you can curate the sources that goes into the templates, and you can sort of you can build you can edit a row. It will turn into a new subtype of pump, and then you can push a button and it will generate. It will lift the data through the template, and you can see the new thing. You can make sure I didn't create a problem for someone else. It still works, and that's sort of the thing that's going to be there. And it will also generate IRIs, of course, and it will keep IRIs and labels in sync across different source tables. That's an easy thing to state, but it's super important. And the second thing is, at some point, I'd like to have also help on building the templates. It's me building the templates and putting the right templates together from the open sourced templates, from the high quality templates. And it's also about, there's a type safety methodology in the Otter template, so you can actually you can work with type safety so that people don't put in strings where there should be numbers and so on. So you have a little bit of data quality assurance there. And the last one is, we would actually like to open up for something like Microsoft Forms or something where I can delegate just one source, just maybe a partial of a source, to a domain expert who should never hear anything about semantic web or anything. I just want to show him, or maybe also the result of a Spark query on the finished ontology. Just say, can you please validate something? And we can delegate that to these true experts that just know, I don't know, liquid types by heart or something, stuff like that.
Yeah, so no, that's great. Yeah, excellent. Thank you. And when you say templates, do you mean Shackle or is it something else?
It's these Otter templates. It's reasonable templates. It's something that has been developed here in Norway, not here, but in Norway, and I think it has been used extensively in this Optique project also. So there is a community of ontologists working on our ontologies using these OTTR templates.
Okay, great. Thank you.